Okay, in this video, we're going to talk about how to crash the network. And what that really means is how can we complete a project more quickly than is currently scheduled, most efficiently. So as a quick review from the last slide, we determined a critical path on our house construction network. We built the network with all the tasks and all the precedence relationships. And then we made a pass from the left to the right through the network where we calculated our early start and early finish times. And then we made a path from right to left in the network where we calculated the latest finish and then the latest starting times. Then using and noticing where the early start and late start were equal, or where the early finish and late finish were equal. Those were tasks on the critical path. And so we determined those tasks on the critical path that have to be completed on time. We noticed the other tasks where we had slack, so that there was some flexibility, and we were also able to tell how long it took to complete the project. Our example from last time is where we ended up, and this is we were able to determine that tasks 1, 2, 4, and 7 were on the critical path. We could complete the project in 36 weeks, and that tasks 3, 5, and 6 had slack. So our question becomes, what if there's a deadline that's not as far away as 36 weeks? What do we do in order to complete the project more quickly and most efficiently? And that's how we determine crashing our project and our project network. So let's take a look at how we're going to do this. The first thing to notice is that there's more information that we have here. You'll see here in this slide that we've got some of the same information. We're given our activities 1 through 7; those haven't changed. The durations, the normal durations, haven't changed. They range from 12 weeks for task 1 down to 4 weeks for task 7. Those haven't changed. But now we're also given the cost to complete each one of those tasks. So for example, clearly it costs $3,000 to complete task 1, all the way down to $15,000 to complete activity or task 7. But now the new information that we have are besides the normal cost, is also these two columns of where we have the crash duration and the crash cost. And these are important columns. So let me explain how these will work. Normally, it will take 12 weeks to complete task 1. But if we work really hard and really fast, it's going to take us 7 weeks to complete task 1. That's the quickest we can complete task 1. If also, for example, if it takes 12 weeks to complete the task, that's going to cost $3,000. But if it takes 7 weeks, it's going to cost instead $5,000. It will be more expensive for us to complete that task faster. And that's just logical. There's more resources, there's more overtime, more materials, so it will cost more in general to complete a task more quickly than originally scheduled. So then we're going to use this information to determine and determine whether it's possible or to complete the project in 35 weeks rather than 36 weeks. And if so, what does the project cost? Okay. Here's our network where we ended up. And you'll notice, again, it's the same information from the previous slide, except it's been rearranged. Now we've got the durations we've got the durations here together, and we've got the normal cost and the crash cost together. Normal duration and crash duration, normal cost and crash cost. So what are we going to do? How are we going to begin this, and what tasks must be crashed? Now, there's a little logic I want you to try to follow here, and I'm going to, it's just as a statement, one of the tasks on the critical path, either task 1, task 2, task 4, or task 7, is going to be the task that has to be crashed. Why is that? Think about this carefully. If you'll notice, 12 weeks plus 8 weeks, plus that's 20 weeks, plus 12 weeks is 32 weeks, plus 4 weeks is 36 weeks. It takes 36 weeks to complete these 4 tasks at best, no matter what you do. And so if we reduce the length of task 6, task 5, or task 3, it's not going to help, because it's still going to take 36 weeks to complete tasks 1, 2, 4, and 7. So one of those 4 tasks has to be reduced. Otherwise, if you pick one of the other tasks, 3, 5, or 6, the length of the project will not be reduced. So the first thing that you'll need to notice is that you must crash a task on the critical path. That's number 1. Number 2 is we're going to use the information from our table to help us determine which of those critical tasks we're going to crash. So we're going to look at only at task 1, task 2, task 4, or task 7. And since our target is 35 weeks, we only need to crash 1 week. So the question is, which of these 4 is most cost effective to crash? So then we're going to do a little calculation. The first thing we're going to do is going to determine how much crash time is available. And we're going to do this because we're going to take 12 weeks minus 7 weeks. And so there's 5 weeks that's available for task 1. And you'll notice here that if we crash those 5 weeks, it's going to cost an additional 1,000 minus 3,000. Oops. Which is $2,000. So it's going to cost us $2,000 to crash for 5 weeks. So what we want to do is now we want to calculate the crash cost per week, which is going to be 2,000 divided by our 5 weeks, which is going to cost us $400 per week to crash our if we choose to crash task 1. And so what we'll do this calculation for each one of our critical tasks, and you'll see here for task 2 we have 3 weeks available. The difference here is $1,500, and the cost per week is $1,500 for each of 3 weeks, which is $500 per week. And then we're going to complete that similar calculation. There's for task 4, there's 3 weeks available. And in this case, the difference is $21,000. And so it's going to cost us, for task 4, it would cost $7,000 per week. Sorry, put that back in, escape. And of course, the 7,000 is is 21,000 divided by the 3 weeks that can be crashed. And then finally, for task 7, it can only be crashed 1 week, and again, it'll cost 7,000 for that week, which is then of course that's also going to be another 7,000 per week to crash activity 7. So now that we know what the cost per week, because we're only going to crash 1 week, well, we're going to choose the smallest, the least expensive one to crash. And so we're going to be comparing $400 per week to $500 per week to 7,000 and 7,000. And clearly you would not pick, you do your best not to pick these two. And so indeed, we're going to choose to crash activity 1 by 1 week to get to 35 weeks. And that's going to be what we're going to do, crash. Task 1. $400. So that's the process that we're going to use to choose to crash task 1. Now, how do we do that? This is and this is a summary. It's a neater. So from among all the critical path tasks, those 4 tasks, task 1 is the cheapest to crash at $400 per week. So we're going to crash task 1 for 1 week to complete the project completion time. And then you'll see the total cost for the project is $75,400, which is the sum of all of these normal costs plus our 1 week of crashing at $400. All right. So how do we do that then? We have to go back to our network, and we're going to change in the network the duration of task 1 from 12 weeks to 11 weeks. And then we're going to recalculate back through the network to determine can this be done? And the answer is, in this case, yes, we can complete the tasks. 1, 2, 4, and 7 are still the critical tasks. 3, 5, and 6 are still have slack. And so we can complete the process in 35 weeks. Were you required to complete for 34 weeks, you would continue that process until for up to 5 weeks. You would still crash activity 1 for up to 5 weeks, but you would want to make sure you do that process 1 week at the time, because there could be another critical path that emerges. So we do that crashing 1 week at a time, or 1 period at a time, until you reach your goal. So that's project crashing, and will be useful in your work. This is also described also in detail on pages 393 to 396 in your textbook. And as always, if you have questions, please get in touch and let me know. Thank you.